Welcome back to the SAT Math Prep series. We're on day 18 now, and we'll be working on more advanced math problems today. Looking at our first, look how far we've come, guys. All of those problems done just from advanced math. Okay. In the xy plane, a line with the equation 2y equals 4.5 intersects a parabola at exactly 1 point. If the parabola has equation y equals negative 4x squared plus bx, where b is a positive constant, what is the value of b? Okay, so if we know it intersects at exactly 1 point, best way to approach this is set y equal to, or isolate y by itself, and that's going to give you 2.25. And now we could set that equal to our equation over here. So since we have this and this now, we can do 2.25 is equal to negative 4x squared plus bx. And what we are used to doing is solving for x at this point, but the question's asking for b, and we can't really solve when there are two variables, except when we use the discriminant formula. So the discriminant formula is b squared minus 4ac. And this formula it has multiple uses. So when it says that there is exactly 1 point or exactly one solution, this is going to be equal to 0. However, I'm going to write this here, one solution, when there are two solutions, b squared minus 4ac isn't going to be equal to 0, but greater than 0. And then finally, when there are no solutions, it's going to be less than 0 for your discriminant. So since we have exactly 1 point here in our question, we're going to use the one solution equation. It's all really the same equation, you just have inequalities for the other two. And to do that, we need to set one side equal to 0. So we have 0 is equal to negative 4x squared plus bx minus 2.25. And now what we're going to do is use our formula. So I'm going to write it one more time for you guys. B squared, here, let me write it like this so we have it in the same format. 0 is equal to b squared minus 4ac. What's b? B is just b. We're solving for b. Minus 4 times a, which is negative 4, times c, which is negative 2.25. Remember, guys, this is our c, this is our b, and this is our a. It's the coefficient before the variable. Since there's no variable here, just imagine it as x to the 0, and that's our coefficient. Let me erase that so it doesn't confuse you guys. Now we move this over to here, and we're going to get a value of 16 times 2.25 is equal to b squared. You take the square root of both sides, and that's going to be plus or minus. And then you get b is equal to plus or minus the square root of 36, which is equal to plus or minus 6. And we're getting two solutions, even though it said exactly 1 point. And this is where you use the context of the problem, and it says where b is a positive constant. So we've now solved for b, but we know it's a positive constant. So instead of it being 6, we know it's going to be only positive 6. And that's going to be your answer. This is a fill-in question. Relatively difficult if you don't know the discriminant formula, but if you know these rules, very important, and it's going to be handy on test day. You should be fine on this problem if you know this background. Okay, next problem. f of x is equal to 9,000 times 0.66 to the x. The function f models the number of advertisements a company sent to its clients each year, where x represents the number of years since 1997, and 0 is less than or equal to x, which is less than or equal to 5. Okay. If y is equal to f of x is graphed in the xy plane, which of the following is the best interpretation of the y-intercept of the graph in this context? Okay, so y-intercept again. We get so many y-intercept questions, so know your y-intercepts. So when is there a y-intercept? When x is equal to 0. Write that down again. Need to know that. So let's just solve for our y-intercept because there's a lot of different numbers here, and we could eliminate our answer choices much faster if we have some numbers. So f of 0 is our y-intercept, and it's going to be 9,000 times 0.66 to the 0. Anything to the 0 is 1, and 1 times 9,000 is 9,000. So our y-intercept is 9,000. So that is starting in 1997 because where x represents the number of years since 1997. If it's 0 years since 1997, we're in 1997. So if we were to have a point, it would be 0, 9,000. However, this 0 represents the years after 1997. So theoretically, it would be 1997 and 9,000. And if we look at our answer choices here, we have a 1,708. We're not even going to read that answer. The minimum estimated number of advertisements the company sent to its clients during the 5 years was 9,000. During the 5 years, no, that's not what we're looking for. The estimated number of, it's not the minimum, sorry. It's not the minimum during the 5 years. That's a different thing. That's like a local minimum or absolute minimum. Okay. See, the estimated number of advertisements the company sent to its clients in 1997 was 1,708. Okay, this is the wording for a y-intercept, but it is the wrong y-intercept as you see here, so we're not going to do that. That leaves us with D. Let's just read it to make sure. The estimated number of advertisements the company sent to its clients in 1997 was 9,000. Yep, sounds correct to me. It has our correct points here and the correct context of the problem. It's not giving it a minimum wording. It's giving in 1997 and $9,000 or 9,000 output, not dollars. I don't know why I said that, but yeah, that output, which is our y-intercept for this problem. Okay, next problem. The first term of a sequence is 9. Each term after the first term is 4 times the preceding term. If W represents the nth term of the sequence, which equation gives W in terms of n? Okay. So we have W equals the nth term. So if we know anything, if anything is 4 times the preceding term, it's going to be 4 to the n, correct? So my first go at this, I'm thinking that we set a list of values. We have n here, and then we have W here, which is going to be, let's just construct a function really quick. If we know the first term is 9, that should be our coefficient. And then if we have anything to here, to the 4n, that's going to be 4 times the next term. So our first term, let's see what our first term is. We can't, ooh, so look, we have to put 1 here because the first term of the sequence is 9. And if W represents the nth term. So if our terms start at 1 and not 0, look what's going to happen here. We're going to have W is equal to 36 as our first term. So that's going to be incorrect. And now, if we do it again, and we have W is equal to 9 times 4, how can we get our first term as 9? We need this to be equal to 0 when n is equal to 1. So to do that, we put n minus 1. So because 1 minus 1 is going to be equal to 0, and 4 to the 0 is 1. So you get 1 here, and w, which is equal to 9 times what we said earlier, 4 to the 0 is just 9. And then just to check, we'll plug in 2. 9 times 4 to the 2 minus 1. I'll write it out for you guys. And I'll write it out here too, just to make it a little more straightforward. And if we check, that is 4 times the value of the first one. We can do it again to make sure, but I wouldn't waste too much time. And if we look at our answer choices, what matches up with this? No, 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 and no. So, a hard problem, not too hard. You could already, like, without even doing the problem, you see 9 times the next value, and you could get rid of those easily and have a 50-50 chance at really getting it right. Okay. We're going to stop here for today. I hope these questions helped, and if you have any questions, please leave them in the comments, and please join me for the next day in the series, where we'll be working on more problem solving and data analysis problem types. I'll see you then.